What you are looking at are a fascinating and highly unusual grouping of more than 1,000 pillars in Western Australia, which jet out of the sand dunes which surround them to a height of up to 3.1 meters or 10.2 feet above the surrounding landscape. These jagged landforms are referred to as the pinnacles and provide a stark contrast with their jagged shape compared to the smooth texture of the sand dunes. So, how did these interesting pinnacles form? Part of the answer is that these pinnacles are somewhat similar to the Mulu pinnacles in Malaysia. They are both examples of karst terrain involving limestone, although they formed in highly different processes. The story of these Australian pinnacles began approximately 150 million years ago when dinosaurs roamed a hot and desert area of Australia in the Jurassic period. As abundant layers of sand piled up in the landscape, the weight of it eventually compressed material until it became a rock known as sandstone. This sandstone was quartz and feldspar rich, having partially originated from ancient plutonic rock. These sedimentary rocks largely remained in the landscape, which resulted in fairly flat terrain which was somewhat prone to erosion, at least in comparison to metamorphic or volcanic rock. When the planet's ice age began approximately 2.5 million years ago, the weather across much of the planet quickly changed. While some areas got colder, others got wetter, while some locations such as the western coast of continental Australia became more windy than it is today. Due to the abundance of sedimentary rock in the relevant area, erosion largely due to wind caused layers of sandstone to break down, first into large cobbles, but as time progressed becoming smaller units of rock known as pebbles, granules, and then finally sand. Sand happened to represent an average particle size of between 2 millimeters and 1/16 of a millimeter. As the wind-dominated erosion continued, large sand dunes were created, towering to as much as 18 meters or 59 feet in height. These sand dunes shifted their position over time, but as this occurred, the climate temporarily became wetter. Although not the primary component of it, the sand contained abundant amounts of calcium carbonate rock, which represented a combination of caliche and material decomposed from ancient ocean-faring life. Calcium carbonate is a basic material which happens to be somewhat prone to partially dissolving when rainfall hits it, as average rainfall has a pH of around 5.7. Thus, when heavy rainfall affected the area, the slightly acidic rainwater dissolved small amounts of calcium carbonate in some sand grains and then seeped deeper into the ground. It moved deeper and deeper until it reached the bottom of the sand dunes where harder rock prevented it from traveling any further. After the rainwater moved away, the calcium carbonate remained, which, as this process repeated tens of thousands of times, left behind a thick, layered grouping of limestone which had varying thicknesses. The sand dunes in the more than 100,000 years since have for the most part eroded away, finally exposing the karst-like landscape pinnacles to the air. Since the sand dunes which surround them are still slowly moving, many pinnacles will eventually be reburied, while others not visible today will eventually be uncovered by sand as the sand dunes shift. In tomorrow's video, I will discuss a particularly explosive, albeit extinct volcanic feature in Australia which originated approximately 35,000 years ago in Victoria, the Tower Hill Mar. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank this channel's patrons on Patreon and channel members on YouTube.